Hello students, today we are going to discuss heat transfer problems. Four rods with different radii R and length L are used to connect two reservoirs of heat at different temperatures. Which one will conduct most heat? The resistance is given as thermal resistance L upon K into A, means R proportional L upon R square. So where radius is less and length is more. So here in this case the option 1 is the correct answer. This will conduct most heat. So out of four choice, the correct choice is option 1. A rod of 1 meter length and area cross section 1 centimeter square is connected across two heat reservoirs at temperature 100 degrees centigrade and 0 degrees centigrade as shown. The heat flow per second through the rod in steady state will be. The thermal conductivity of material of rod is 0.09 kilocalorie per meter per second. Dear student, the heat flow per second delta Q upon delta T, this is equal to K 0.09. Let's maintain kilocalorie, okay? Ka. A is given 1 centimeter square means 10 power minus 4 meter square. What is temperature gradient? This is 100 minus 0, 100. And what is distance? This is 1. So out of 4 choice, this is 9 into 10 power minus 4 kilocalorie per second. This is the answer. Out of 4 choice, the correct answer is option 1. The coefficient of thermal conductivity of copper, mercury and glass are respectively Kc, Km and Kg respectively, such that Kc greater than Km greater than Kg. If the same quantity of heat is to flow per second per unit area of each and the corresponding temperature gradient are Xc, Xm and Xg. Temperature gradient means loss in temperature per unit length. Loss in temperature will be more in case when conductivity will be more. So conductivity of copper is more. So loss in temperature will be more here. So temperature gradient will be more in case of copper. Okay. So copper will be more than mercury, then more will be in glass. So option out of 4 choice, the correct choice is option 2. If L is the length and A is the area of cross section of rod and K is thermal conductivity of material, then thermal resistance, this is given as L upon K into A. So out of 4 choice, the correct choice is option 2. Two rods A and B are connected in series. A is shown in figure. The conductivity of A is K1 equal to 100 watt upon meter degree centigrade and conductivity of B is K2 equal to 50 watt upon meter degree centigrade. The free ends of the rod A and B has temperature 30 degree and 60 degree respectively, the temperature of the common meeting point. Dear student, in series circuit, heat flow rate remains constant. This is very good question. So we apply that equation. K1 is given 100. A, let us assume temperature at the junction is theta. So 30 minus theta upon 1 equal to K2 is given 50. A, theta minus 60 divided by 2. After solving the equation, A will get cancelled 50, this will cancel by 2. So 60 minus 2 theta will be equal to theta minus 60 into 2. So this is 120 minus 4 theta. This is equal to theta minus 60. So 3 theta will be equal to 180. So theta will be equal to 60 degrees centigrade. So out of 4 choice, the correct answer is 100 A 30 minus theta upon 1 equal to K2 50 A theta minus 60 upon 2. Okay, this is 2. Oh ho ho. This was already, so this 2 will become 4. Okay, so let's solve again. This will be 4 into 30 minus theta equal to theta minus 60. So 120 minus 4 theta equal to theta minus 60. After solving this, we will get 5 theta equal to 180. So theta equal to 36 degrees centigrade. So out of 4 choice, the correct choice is option 1, approximation. Okay. Option 1 is the correct answer. Two identical square rods of metal are welded end to end as shown in figure 1. 20 calorie of heat flows through it in 4 minutes. If the rods are welded as shown in figure 2, the same amount of heat will flow through the rods in. Dear student, this is the concept. Delta Q upon delta T, this is heat current. This is equal to delta theta upon R. R is thermal resistance. So delta Q equal to delta theta upon R into delta T. So delta Q is constant, delta theta is constant, so delta T proportional R. So in our question, when rods are connected in series, thermal resistance is here R equivalent equal to 2R. When rods are connected in parallel, here R equivalent is R by 2. So what is, when resistance is less, time is also less, okay? So here, this will be 1/4 time. So out of 4 choice, the correct choice is option 1. So in 1 minute time, the same amount of heat will flow through the rod in second case, okay? Two rods of length D1 and D2 and coefficient of thermal conductivity K1 and K2 are kept touching each other. Both have the same area of cross section. The equivalent thermal conductivity in case of series circuit. The equivalent thermal conductivity, this is D1, D2, not L1, L2. So K equivalent is what? D1 plus D2 upon D1 upon K1 plus D2 upon K2. So D1 K2 plus D2 K1 upon D1 plus D2. D1 plus D2 upon D1 upon K1 plus D2 upon K2. Okay, harmonic mean. So this is the option 4 is the correct answer. The emissive power of a body as used in Kirchhoff law may have values such that its value ranges from 0 to 1. So out of 4 choice, the correct choice is option 1. This is also very good question in radiation. If transmission power of a surface is 1 by 6 and reflective power is 1 by 3, then its absorptive power will be. We know that T plus R plus A remains equal to 1. So this is 1 by 6. This is 1 by 3 plus A equal to 1. So A equal to what? 1 minus 1 by 3 minus 1 by 6. This will give us 6. 6 minus 2 minus 1. 3 upon 6 means 1 by 2. So out of 4 choice, the correct choice is option 2. Option 2 is the correct answer. If at temperature T, the emissive power and absorptive power of a body for wavelength are E lambda and L lambda, then according to Kirchhoff law, is ratio of spectral emissive power to spectral absorptive power remains constant, E lambda equal to A lambda. Okay. So out of 4 choice, the correct choice is option 1. A substance when at high temperature emits wavelength lambda 1, lambda 2, lambda 3 and lambda 4 only. And when this substance is at low temperature, then it will absorb only the following wavelength, all wavelength, okay? This is according to Kirchhoff law. So option 4 is the correct answer. Four bodies of specific heats S1, S2, S3 and S4 are cooled in the same surroundings if S1 greater than S2 greater than S3 greater than S4 and temperature of all the four bodies is same, then the specific heat of body which cools fast, the body which body will cool fast? Only the same body which will increase the temperature fast. Okay, so the when the body will having specific heat less, okay, will cool fast. So specific heat less for S4. Okay. So out of four choice, the correct choice is option 4, S4, because S4 is having least specific heat, so this will cool fastest. Two bodies A and B are kept in an evacuated chamber at 27 degrees centigrade. The temperature of A and B is 327 and 427 degrees centigrade respectively. The ratio of loss of heat from A and B. Loss of heat. 327 means how much? This is 600 power 4 minus 300 power 4. And then 427, 273, 700 power 4 minus 300 power 4. After solving this, we will get 36 into 36 minus 9 into 9 divided by 49 into 49 minus 9 into 9. So approximately this will come 36 into 36. This will come 1296 minus 81. This will come 1215 and 49 is to 49. This will come 2401 minus 81. This will come 2320. So 1215 divided by 2320. This ratio is 0.523. So out of four choice, the correct answer is option 1. Option 1 is the correct answer. The effective area of black body means MECT equal to 0.1 meter square and temperature is 1000 Kelvin. The amount of radiation emitted per minute. A 0.1 sigma Stephen constant 5.67 into 10 power minus 8. T4 10 power 3 power 4. EA sigma T4. Okay. After solving this, this is per second. So per minute will be 60. After solving this, we will get 1.34 kilocalorie. After four choice, the correct choice is option 1. If the rate of emission of radiation by a body at temperature T Kelvin is E, then graph between log E and log T will be E equal to sigma T4. So log E equal to log sigma plus 4 log T. This is Y equal to mx plus C. So correct choice is option 2. Option 2 is the correct answer. A body takes 4 minutes to cool from 100 degrees centigrade to 70 degrees centigrade. This is very good question for NEET and JEE 26. And room temperature is 15 degrees centigrade. How many minutes will it take to cool from 70 degrees centigrade to 40 degrees centigrade? Rate of cooling is directly proportional to excess of temperature. Dear students, rate of cooling is directly proportional to excess of temperature. More is the temperature difference between body and surrounding, more will be the time taken. Okay. Now body is taking 4 minutes from 100 to 70. 100 to 70, 4 minutes. This is K constant. 100 plus 70 upon 2. Average temperature minus surrounding temperature. So 30 upon 4 equal to how much? K. This is 85 upon 2 minus 15. Now this is equation 1. And second equation 70 to 40. Time. This is K. 70 plus 40 divided by 2 minus 15. This is equation 2. So this is 30 upon T equal to K. 30 upon 2. 15 minus 15. 70 to 40. 70 to 40 means 30 upon to 15 and room temperature is 50. So this method, this approximate method will not work. Directly you have to answer. Here how much is the temperature difference? 100 minus 70, 30. And how much is the temperature difference? 70 and 40. This is also 30 degrees centigrade. Okay. Again 30 degrees centigrade. Because temperature difference between body and surrounding. This is 100 minus 15, 85. Now 70 minus 15, this is how much? This is 55. Okay, so temperature difference is lesser. So time taken will be more, means it will be more than, okay. Then what you have to do? You have to apply exact method, okay. What is that exact method? That I am telling you. This is rate of cooling. Minus dt upon T minus Ts equal to minus K dt. ln T minus Ts equal to minus Kt plus C. This is the equation. This equation, make use of this equation and solve this equation, okay. Temperature of two hot bodies B1 and B2 are 100 degree and 80 degree centigrade. The temperature of surrounding is 40 degree centigrade. At T equal to 0, the ratio of rate of cooling of the two bodies R1 is to R2. Rate of cooling is directly proportional to temperature difference. 100 minus 40, 80 minus 40. So this is 60 upon 40. So ratio of rate of cooling is 3 upon 2. So correct choice is option 1. So out of 4 choice, the correct answer is option 1. According to Newton's law of cooling, ms d theta upon dt equal to minus k theta minus theta 0 if sigma is the Stephen constant, A is the surface area and of the body and T0 is the temperature of the surrounding, then the value of K on the basis of Stephen Boltzmann law is 4 EA sigma T02. So out of 4 choice, the correct choice is option 4. Wayne's displacement law is shown by the following relation: lambda m t equal to v. Then graph between log t and ln lambda m will be equal to minus ln t plus ln p. So graph is this. Option 3 is the correct answer. Out of 4 choice, the correct answer is option 3. Okay.